you, Thomas. I hope everything works. And it's really a pleasure to be here and to pay tribute to Eric, because he was a great inspiration to all of us, and he was a great motivator, especially in, sort of motivating us to store a lot of data, to gather a lot of paleoecological data, and to store it in the databases, and also to facilitate asking many ecological questions. And some of these questions I'm going to show today, so that's the direction I'm going to go in my talk. But before I do so, I also want to share a little memory with Eric, which goes back to 2017. And it was an event where both of us were invited to South Korea by Sang-Heon Yi to teach a small workshop. And obviously Eric was teaching Neotomatilia workshop, and I joined in, and I taught a couple of days the landscape reconstruction algorithm and how to reconstruct quantitatively land cover based on pollen. And I guess you will hear more about it today in the following talks. We also enjoyed a lot of discussions with Eric, and also a lot of good Korean food. So back to my talk. Today I want to say something about how we can interpret large pollen data sets in terms of ecological gradients or ecological characteristics. And of course, all of you know that pollen basically represents plants. So pollen is a reflection of vegetation growing in the surroundings of a place where we collect our pollen data. So we gather our pollen assemblages. And these assemblages have to be, of course, somehow interpreted, and they can be interpreted in terms of diversity. So we have a lot of studies today covering the relationship of pollen diversity versus vegetation diversity. And also we have a lot of studies emerging in recent decades covering some kind of quantitative interpretation of pollen data in terms of being able more realistically represent and reconstruct the vegetation cover. But on the other side of the story, there are vegetation ecologists, and if I may say, there are geobotanists. I myself consider myself as geobotanist, so plant ecologist. So those are scientists, mostly this field developed in Central Europe. So scientists describing vegetation communities, and they are also characterizing ecologically these vegetation communities. And one of these pioneer works was done by Heinz Ellenberg, who already in the 70s developed those famous Zeigewerte, or Ellenberg's ecological indicators. And these values can be actually used, they are expert values, and they can be used to infer, without any measurement in the field, to infer some ecological properties of certain plant community. So they are given some examples of what these ecological indicators may be. So for instance, Ellenberg N is referring to some kind of nutrient content, and each species is attributed this ecological index to infer the nutrient content in the habitat. A similar way, it can be done, for instance, for Ellenberg L, which is referring to light. So there's some kind of light demand of each taxon, each species. And all these assemblage of taxa can then point at the community level ecological characteristics. So we may ask ourselves, if ecologists have these assemblages of plants, so why don't we use them in paleoecology, in pollen data, if we have our pollen assemblages? Of course, we can do it, but there are some kind of obstacles preventing us to do it easily. And of course, these obstacles are connected to some kind of translation mechanism between actual pollen type, actual pollen taxon, and plant taxon itself. So to be able to connect these ecological indices to pollen data, we actually need something what is pictured here at left. So some kind of translation table for pollen taxa into plant taxa. So you can see some sample from a family of Apiaceae, where they are at left, there are many species of plants, and they are linked based on different Central European literature, Central European pollen keys to different pollen taxa. So first, I want to highlight some kind of pioneer works that have been done already quite a long time ago, and one of them is the pioneer work, I would say, by Gaillard et al. And they have been basically doing the similar thing what Heinz Ellenberg did in the 70s. And they took many modern samples of pollen in the vegetation, and they have measured many ecological properties, such as the acidity of the habitat and a certain grazing and other disturbance pressure. And based on that, they derived and they basically transferred it to pollen taxa. So here we got the first set of sort of ecological attributes, what they say that these indicator values are acute palynological equivalents to Ellenberg's ecological values. So basically we have a set of quite many pollen taxa already, and they have these ecological attributes that potentially can be used to reconstruct some ecological characteristics of pollen assemblages in the past. Another story I want to highlight is actually the story of mine and other colleagues, where we used ecological indicators to sort of interpret the interglacial vegetation dynamics. And this is one site derived from quite an old interglacial in Denmark. And the advantage of using these ecological indicators to interglacial pollen taxa is that there are not so many pollen taxa during the interglacials. So we have mostly trees, which are easy to be tracked in terms of plant species, and there are only a few herbs. And when we used it and we interpreted ecological indices in this sequence, so you can see there's, for instance, dynamics of soil reaction on nutrients, that they have a decreasing trend. And on the other hand, there is an increasing trend in the light demands of the communities. Another quite nice story, which is more recent one, is the story by Trin Raitalu, who used ecological indices on already multiple sites, but still she used quite a few pollen taxa, about 21 pollen taxa. And this was done, I guess, in Baltic states, Estonia and Latvia. And she interpreted on many sites ecological trends, especially again in soil reaction and nutrient content throughout the Holocene. And you see that especially the soil reaction has a similarity, quite large similarity with the interglacial vegetation dynamics. So here at left, I just noted few obstacles in doing this on larger data sets. So certainly there is a need for much larger pollen translation data set, which we still don't have fully developed. And of course, also the ecological attributes, they are often regionally developed, regionally constrained on the regional vegetation, regional flora, and also pollen plant species, they are regionally specific. So we did a study, and this is why it wasn't done on the whole EPD. It was only concerning Central Europe, where we have quite a good database of pollen data. And so we tried to develop, at one side, we tried to develop this pollen plant translation table, and we tried to use a newly developed disturbance ecological index, which you can see here. So there is a paper about it, and there's some kind of scheme how this disturbance index is developed and how it works. So we tried to connect it with our pollen data, which spans across Czech Republic, Slovakia, part of Germany and Poland. and we tried to use this ecological index to ask basically two main questions. So one question was that we were interested in some kind of Holocene disturbance history, Holocene disturbance dynamics in temperate ecosystem in general. And this was also driven by the fact that recently these disturbances in the forest are increasing due to human pressure and also climate change. And the other question we were asking was that we wanted to test the ecological theory, and this theory concerns intermediate disturbance hypothesis, which is the theory that determines, based on ecological observation, it determines the number of species in the ecosystem under certain levels of disturbance. And it says that there should be maximum amount of species under intermediate disturbance. And we wanted to test this, whether this could be seen also during the Holocene. And why we use this disturbance index, this newly disturbance index, is that there are also some constraints when we are using disturbance proxies from many different records. So for instance, we can infer fires from charcoal, and we can infer grazing from NPPs or from only certain pollen taxa, or we can infer deforestation. But there wasn't really a complex disturbance proxy that would basically point at all the disturbances we could see in the data summed up. So this is briefly how we did it. We took many pollen assemblages, and actually from half of our pollen assemblages, we calculated diversity, so some kind of rarefied pollen richness. And from the other half of pollen assemblages, we calculated the disturbance index, the whole community, the whole assemblage disturbance index. And this has had to be done somehow repetitively, because we had to assign plant species to each pollen many times to sort of get the variability and get the significance. So here are some results I want to show. The black line represents the Holocene dynamics in this disturbance. So it shows that there is a decreasing trend, which is going to this minimum around the middle Holocene, around 6,000. And then we observe a slow increasing trend, and then a sharp increasing trend towards the present. And you can compare it with different diversity proxies here that show basically a steady increasing trend towards the present. So what we were interested at the start, what I showed at the start, was this disturbance diversity relationship. And here's a short animation that shows this relationship being calculated during the whole post-glacial and in 400-year time intervals or 500-year time intervals. And it shows basically that there is a changing shape of this relationship, leading from a hump-shaped relationship into the monotonic, which is going straight towards. At right, there's another sort of sum up diagram which shows midpoints of the observation. So we basically have disturbance at maximum diversity, and it's also changing in time. So that's basically a summary of this figure. And the last figure I want to show is again kind of a summary figure that this disturbance diversity relationship is changing through time. So in the old times, we really have this hump-shaped relationship, whereas starting at 4,000 BP, it changes to a monotonic curve. So we can basically say, to sum up, to conclude, we can basically say that this ecological theory is only validated in the older part of the post-glacial, whereas in the recent time it's changing into this monotonic curve. And there are some reasons behind it. I don't want to discuss all of it just now. You can read it in our paper. But there is, of course, during the hump-shaped phase, there is a competition colonization trade-off, whereas during the monotonic part, there's probably a spatial mosaic which is developed which is basically originated due to human impact, and there is much more effect of new species, new invasive species arriving, and also effect of species pool. So with this, I want to thank mostly Eric for motivating me to work with these databases. Certainly there is some kind of take-home message that we need to develop these translation tables to be able to ask even more ecological questions in this way. And there is also a big thank to my colleagues. Without them, I wouldn't be able to perform this study. So they helped a lot. Thank you very much.